Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM Arts students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.
Today's episode is a very special one because we have a special guest on the show. And Nicole, do you want to introduce yourself?
Sure. So thank you for having me here. My name is Nicole Lloyd Ronning. I'm a computational physicist and astrophysicist at Los Alamos National Lab.
If all of our hosts today want to say their name, I'm Shaylee.
Yeah, I'm Tulsi.
I'm Hattie Rose.
And I'm Wyatt.
Lovely to see you all here. Thanks
Yeah.
for talking with me.
Yeah, it's great to have you here.
Thank you.
Okay, yeah. So, Nicole, what made you interested in space in the first place?
Good question. So for me, it was when I was 4 years old. I remember looking up at the moon one night and just thinking I needed to go there. And it may or may not have been related to a fight I got in with my brother, and I wanted to get as far away as possible. But the feeling never went away. I always thought the moon was so beautiful, and I wanted to know what was up there. I wanted to know all the points of light in the sky, the stars, how did they work? What were they? What did it all mean? And I thought the way to learn about it was to go there. So I had always just wanted to be an astronaut growing up. I thought I need to go to space so I can learn what space is and what's out there. So it was where it all began. I was 4 years old looking at the moon, and it was beautiful, and I wanted to go there and learn more. And I actually looked into being an astronaut. It started in high school when I thought I would go the route of being a pilot. At that time, we had the space shuttles, and I was going to be a shuttle pilot. But I learned very quickly that the requirements. Do you all know what the requirements are to be a shuttle pilot, or were? I don't know what it's like now, but back in the 90s, does anyone know what you have to be able to do that?
I think with most astronauts, they had some, they've been in the Air Force, they've flown a lot of fighter jets and stuff. Would that be correct?
Absolutely. Yeah. So I thought, I guess I should join the Air Force and all this, and you have to get your pilot experience, or traditionally that's how they would get their experience flying. But the physical requirements, perfection to the point of I'm a healthy person, thankfully, but my eyes aren't perfect. I don't have 20/20 vision uncorrected. And so that automatically disqualified me at the time. So when I learned that I, wasn't a perfect specimen in the definition of at the time, I said, I guess that means I have to get a PhD in physics. I mean, this is me in high school not having any clue. From what I've met and learned of y'all have a clue of what that means, but I can tell you I had no clue what that meant to get a PhD in physics. But I just thought that was the only other option to becoming an astronaut. But the very good news was that I loved my physics class in high school. I had a phenomenal physics teacher, and I had a great math teacher too. So I was pleased to discover this was a route I wanted to pursue, that I was going to go ahead and try to major in physics in college. The funny thing about my path at this point is really I don't come from a family of scientists. Part of the reason I had no idea what I was talking about is because it wasn't in my family culture or really my school culture. I had moved every 2 years growing up all over the world because I had a father who served in the military, and we were constantly stationed somewhere else every couple of years. some of the schools I went to, including the high school I graduated from, didn't offer higher level math and science classes. So there wasn't a lot of that around me. And I just got very lucky in that I did have a really good physics teacher in my final high school. I was in 3 different high schools, but the final one showed me how cool physics is. And then I still had this love of space from always wanting to be an astronaut. So that got me started on the path of pursuing that with my studies.
What exactly, for anyone who doesn't know, where do you work and what does working there entail?
Yeah, so I work at Los Alamos National Lab, and I'm in the group. It's a very big place with every kind of science you could ever dream of. And my group is called Computational Physics and Methods. And we have a wide range of expertise. So there's a group of us who are astrophysicists, but there are folks who studied math in college, and there are folks who studied material sciences and a whole bunch of different things. And we all come together to kind of work on how we can solve different problems with our computers, with these big simulations of different systems. Like for me, one of the many, many things I study is a massive star. As it shines and burns through its fuel and lives its life, it begins to use up all that fuel and it's not burning anymore, and it begins to collapse. And in that process, it creates a black hole, and the material around the black hole is spinning really rapidly, or the star is spinning rapidly as it collapses. So you have this black hole at the center and material spinning around it. And this ends up launching this powerful jet of material out into space. And we see that. We observe it with satellites and telescopes on Earth. And these are named gamma ray bursts, but they don't just burst in gamma rays, they burst in all the types of light. So gamma rays are a type of light, but we have optical light and radio light and X-ray light. And these gamma ray bursts make all the light, and they're the brightest things in the universe. And we see them about once a day with all these different telescopes. And so I study all the physics of that, all the processes, mostly through computer simulations of those processes, and also with my pen and paper and the physics that I learned in school for sure. But yeah, my day involves looking at that problem or the physics of that problem in a whole bunch of different contexts and with different types of codes that solve different types of equations and setting up different simulations and then trying to understand all of those results. So Tulsi put in the chat, which I'm so excited, wasn't the first paper about gamma ray bursts published by Lanel scientists? And the answer is a resounding yes. It's just the coolest story in the world. In the 60s, the United States and at the time the Soviet Union had a treaty to not test nuclear bombs in space. But we each kind of wanted to monitor the other. So Los Alamos Lab built these satellites called the Vela satellites. The satellites could catch gamma ray light, and they were specifically looking for the gamma rays that come from a nuclear explosion. But they didn't see nuclear bombs going off. They did see a burst of gamma rays coming from outer space. That burst of gamma rays is what we now call a gamma ray burst. Over decades of a lot of hard work, we've realized what these things are. It's these massive stars that collapse and make a big explosion, or you can actually get them also from colliding two stars. We've just gained a lot of knowledge over the years, but we have a lot of physics to learn about them. One thing that makes them so special to study and allowed me to have an entire career studying them is that they involve so much physics, and there are so many open questions. They involve physics that we can't access in laboratories on Earth. They have just too much energy. They give off more energy in 10 seconds than the sun does in 3 billion years. That's how bright they are, and we can see them to the edges of our observable universe. They're these extreme laboratories for doing physics. And back to the forensics part that Tulsi was mentioning in her future pursuits, we obviously can't go to one and do an experiment like we do in normal physics labs here on Earth. So we have to just passively sit here and gather the evidence that hits us, hits our satellites and hits our telescopes, and put it together in a very forensic style way. We're sort of doing space forensics when we're doing almost any astrophysics in some ways. We're just passively gathering evidence that the universe sends us and trying to put it together to make sense of. And so broadly, when you ask kind of what do I do day to day, it is exactly that in a broad sense, not only with these objects, but many different things, sort of gathering that evidence and putting it together to make sense of it.
Yeah, you said you worked with gamma rays, explosions, gamma ray bursts, as well as black holes. What would you say is your favorite specific area of study? What's your favorite specific area that you like to research or to look into?
Oh, I love that question. And it's a super hard one because I'm not kidding you when I tell you, like, I love every part of it. I find so interesting, and every part that I begin to look into, I get wild about. But I do think I can name a favorite. Were you the one that said you are getting more and more interested in how the universe began? Okay.
Yeah.
And you're like the Big Bang and how it all started. And then are you also interested in how it went on from there?
I think so, yeah. I'm pretty interested in the whole concept of it. I think when I think too deeply about how the universe started, though, I kind of start to have an existential crisis. So I think also thinking about the present helps a little bit and the future of space. But I'm curious about how it began because we really don't exactly know.
To answer Shaylee's question, my favorite part about gamma ray bursts is because they're so extraordinarily bright, we can see them farther away, which means further back in time, than any other object in our universe, other than what's called the cosmic microwave background, which is sort of the relic leftover light from the Big Bang. But in terms of like astrophysical objects that are out there, like galaxies and stars, gamma ray bursts are the brightest, so we can observe them out to the farthest distances. And that means the furthest back in time. And that lets us get clues about what the universe looked like in those early days just after the Big Bang, and then how it changed over time. So for me, my favorite part is that that's the study of cosmology. And for me, gamma ray bursts allow us to do cosmology really well. And that's my favorite part and what I've written a lot of my papers on, especially in the last 5 years. It's so fun. Yeah.
I have a question. Were they like more common in the earlier universe or more common now?
Oh my God. That's an amazing question that I was just thinking about today. I'm not kidding. Before this before this Zoom call, I was sitting there working on that problem. We're not really sure other than the following. So do you all have an idea of like how the history of the universe evolved in a very broad sense? Like, have you been given that story or have you studied that at all in school? Would it be helpful if I gave like a brief 1 minute?
I think a little brief explanation of it, just even for our viewers, if they don't know what it is, a little explanation is always good.
Okay. So, I mean, as Hattie Rose said earlier, we don't really know how it all began to begin with, but something began. There was an expansion. And for a long time, our universe was sort of this hot soup of radiation and particles, and they were all kind of intertwined and combined. But everything was kind of expanding. The universe was getting bigger and bigger. And there was a point where there were like electrons and protons and light particles all bumping around. But then as it cooled, the electrons and protons combined to make hydrogen. And when that happened, it was like this kind of magical time where now the light, the radiation could stream out freely. And that's what I was mentioning earlier, this thing called the cosmic microwave background that we can observe, that relic radiation from the Big Bang. But on the other part of that is all these hydrogen atoms sitting around, and there was some helium there too. And there were little clumps here and there, and those began to clump and form gas clouds over the history of our universe. So our universe is expanding, but mass, like hydrogen atoms and helium atoms, are coming together to form clouds. And there's other ingredients in there that we can get into, like dark matter and things like that. But for now, just in terms of some of the directly observable stuff from which we gather light, we have these clouds of gas condensing and and they're starting to form stars, and those stars are coming together and forming galaxies. And this process kind of was slow. It took some time. It was about a few billion years after the Big Bang when stars are really starting to form more rapidly. And when you ask the question of like, are gamma ray bursts more common in the early universe or today, I would say they seem to be common in the early universe when stars began to first form all the way up until today. But they kind of peaked at the time in our universe, which was about maybe a few billion years ago, when the star formation peaked, when all the clumping kind of was really active and all the stars were forming in a very rapid way. So we don't know for sure, like with many things in space and in science in general, but we think that they were common when the stars were forming because they're related to stars. They result from the death of massive stars. And then they continue to be common today, but not quite as much as the time when star formation was really going on rapidly. I don't know if that makes sense. Like, talk to me a little bit. Tell me follow-up questions or what didn't make sense there.
Well, I mean, just hearing you talk, I can kind of tell that like you study and work with things that I feel like a lot of people don't really fully understand, and even like we're still learning about it. So do you think there's anything that people like think they have but they don't, or like any misconceptions that people make about that kind of thing?
Oh, that's a really good question. I do think from my experience with all my lovely colleagues all over the world, everybody kind of has their favorite theories about this or that, myself included. There's things I think are really great explanations, but there's probably another explanation that's just as good. And we have some evidence for the explanation I like, but it's not proof. It's just evidence that supports it. What I think we really have right, though, that makes me always excited to continue my work and get up in the morning is the laws of physics. So I think, I take a lot of comfort in that, in the sense that like we may not understand how to solve some of the really hard equations and the systems that are really kind of messy, involve a lot of different processes. But we do understand like Newton's law, that F equals ma. That is true. And we know energy is conserved and we know momentum is conserved. Some of these things that I learned in my first physics class are so like fundamental and have played out in every bit of work I've ever done in my field. That is very comforting and grounding. So that even when I have an explosion that involves this jet that goes near the speed of light, and I don't know how to describe really how the particles are moving in that and how they're radiating exactly and how the magnetic field looks, I do know some things that have to be true based on the laws of physics that we have proven again and again. So yeah, to me, the exciting part is all the stuff we don't know. It's like, what are we missing in how we're applying the laws of physics? And what are we missing in the ingredients that we're putting into our equations? That's the part we don't know. And, we have a lot to learn and we need some fresh ideas. So I'm hoping all of you are, excited about any part of any of this and want to look into it or pursue that at some point.
Yeah, and so you just mentioned how your first physics class, was fundamental in learning all of these basic concepts. Did you want to go a little bit more into how your career started, how you got into astrophysics?
Sure, I'm happy to. So yeah, I kind of ended that story in high school when I said I really loved my physics class. I still wanted to be an astronaut and I thought I had a PhD in physics. So I knew I had decided kind of my senior year of college when it was time to apply for college that I wanted to major in physics. I was living in Hawaii at the time. That was where my last high school was in Honolulu. And my school, like I said, it was not academically rigorous. And I think at the time the graduation rate was 46%. And so a smaller percentage went on to college. So there wasn't a lot of institutional knowledge or, how to go about that process. Similarly from my parents, my mom didn't go to college. My dad went to the University of Nevada, which was a state school, so that he could afford. So anyway, all this to say, I didn't know what I was doing, but I knew I wanted to major in physics. And I also knew I had to pay for my own college. That was another factor that was coming into my next step in my career. And I applied for colleges kind of threw darts at the board at the U.S. map of places where I knew had good physics programs and where I could also apply for financial aid and scholarships. And they were very state schools around like University of Arizona, University of Colorado, stuff like that. And then my college counselor had met somebody who had gone to Cornell and encouraged her to encourage me to apply. And she basically forced me to apply. I loved her and I took her advice, but I didn't envision myself in upstate New York from Hawaii. But she made me apply. I managed to get in and they managed to give me the most generous financial aid. So I ended up going to Cornell because I could afford it and I could pay for it myself. I studied physics there and doors were opened for me because they are so resourced. And I could immediately hook up with mentors who did research. I didn't even know that was a thing. I definitely didn't know you could get paid to do it because I did have to work through college. And after my sophomore year, I joined a research lab where my job was to do research. And that just opened up a whole world of, wow, I can actually kind of go to space without going to space. And that's where a switch happened for me that although I still wanted to be an astronaut, I realized I could probably learn more and go a lot farther, so to speak, in terms of how deeply I could go into space by doing it on my computer or through telescopes. And so I decided through college, I had a great experience at Cornell. I enjoyed majoring in physics, great professors, and I applied to graduate schools. I knew I wanted to do a PhD, but this time I knew I wanted to be back where there was sunshine. So I went out to California to Stanford University to get my PhD. In that case, in physics, and I think it's still true, I was certainly at the time, they pay you a stipend to do a PhD. So now the financial burden was removed and I got a living salary. So yeah, and there at Stanford is where I learned about gamma ray bursts from my advisor who just happened to have a grant to study them. He normally studies the sun, but he's like, I got some money from NASA to study these explosions. Do you want to work on it? And I was like, sure. And loved it. And things just took off from there. It was, that was everything. So I got my PhD in 2001. And this was a big time of discovery for gamma ray bursts. It's when we got more observations in all the wavelengths of light, not just gamma rays, but optical light, radio light, X-rays. And we learned that they are massive stars exploding or two stars colliding. And so the field was just blossoming at that point. It was a great time to do what I was doing. Yeah, and then I went on to do a postdoc. So usually after you get a PhD, if you want to stay in research, you do these little 2 or 3 year positions called postdocs. And my first one was in Toronto at the Canadian Institute for Theoretical Astrophysics. This time I was pretty securely loving doing theory, which meant at that time there was a mix of paper and pencil and computational. But the computational stuff was you wrote your own codes, which is what I did. It wasn't these like big parallel computer simulations that we do now. But anyway, I kept going with it, went to Toronto, and then my second postdoctoral position was here at Los Alamos National Lab. So I took a position here for a couple of years. It was really awesome to be at the place where gamma ray bursts were discovered. That just never, every day I thought about how cool that was. I still do. I think it's amazing. And then I took a break for about 12 years at that point. So I did about a year here as a postdoc, and then I stepped back from my career for about 12 years, but came back in 2016 or so through a fellowship through the American Physical Society. Jumped back into the same field, but the world had changed in the sense that now theoretical physics really meant computational physics. So there was this huge learning curve to learn how to run a big simulation. And Python it had been invented before, but not used. And now it was everywhere. So I had to learn like a lot of different code languages that weren't used in my field before. Then I've been working in the same group since that time on these objects and all the physics involved and loving it ever since.
That is really interesting. I mean, that's awesome. I have a few questions, but one that I want to ask right now is have the opportunity to go to space, say the International Space Station, or maybe not the ISS, because that will be deorbited in 2030, I believe. Say another commercial space station, or even go on an Artemis mission and go to the moon. Would you still consider going?
Absolutely. I'd be on there tomorrow if they let me. Definitely. Hopefully you'll be on there too, Wyatt. What is your plan? How do you plan to go forward with that dream, which is great?
Early
Do you want to study a technical field in college? Is that a route you want to pursue? Like a physics or math or computation or?
I'm not really good at math or science. I think what I would want to do that's space related is kind of like what I'm doing right now here at STEM Arts with the podcast. Not specifically STEM Arts, but media related, because this podcast has been a great opportunity for me and everyone else here. And I get to talk about the stuff I love. I like video editing. And I think maybe eventually I could help other space flight companies with their live launch broadcasts. Something like that, like live production. I don't know. It's cool, but I should probably ask you another question.
Well, actually, before you do, can I ask, I'm curious of the rest of everybody here who would go to space if they had the opportunity.
Yeah, definitely. If I had the opportunity to, I would love to go to space.
Awesome. How about you, Hattie Rose?
I don't know. I think I'm pretty fascinated with it, but I also kind of have like a fear of like dying in space. Not to get like dark, but it seems a little bit scary. But I think it'd be cool if we went to just like the surface right outside of Earth. I'm forgetting what the name is right now.
Yeah.
Like where it's kind of like that safe area.
Absolutely.
Hattie, you gotta live a little.
That was the key word there, Tulsi. Like she wants to live. That's the thing.
I would go to space if I had the chance. So I feel like because I've heard all these stories of people who go to space and then they never really see the world in the same way because of just that existential kind of experience. And I would want to see that.
Yeah, it would be amazing. And I'm so narrow-minded still, I think, about what it means, like, to go up. And back to Wyatt's point about the way, what you might study or whatever. I mean, as we all know now, like a wide range of people who do a wide range of things go to space. And I don't know exactly what our future in space looks like, but we are all thinking about it, right? And we need everybody from doing a lot of different things, a lot of different expertise if that's where we're headed in the long run, one way or another. Why I didn't mean to cut you off because you said you might have another question. So if you...
Do you see humanity leaving the solar system ever? Or like going to another star system? What was it? Proxima Centauri?
Proxima Centauri. I don't know. I've done that calculation. Like, how long would it take us to get there? And it's very long. It's about 4 light years away. So if we could magically travel at the speed of light, which we cannot, it's physically impossible, but let's say we could get close, it would still take many, many, many years to get there. And the way that I've thought about it, if we ever wanted to do something like that, is, we would need a system, a spacecraft, where we could have multiple generations of people. Like the people who got on to start with are not the people who are going to make it there. Hopefully, I'm missing something in how our technology could develop for speeds of spacecraft, but with what we can currently do and with what I currently understand, just would take too long. So I've never really entertained the thought of getting out of our solar system. I definitely have thought about going to Mars. That's something I've, wanted to do. Like humans can get to Mars and that's also a long haul, right? It's like a year to get there, and then you hang out for a little bit and another year to get back. So you're giving up a chunk of your life. But that, that's sort of where, in terms of the next step of human exploration, where my mind goes is like within our solar system. It's sort of amazing to me, although I study things that are in other galaxies billions of light years away and nothing like close to us at all. I'm always blown away by the fact that we still don't know a lot even about our own local environment, our own solar system, including the presence of life on some of the moons around Saturn, let's say, or, some of the other objects in our solar system. So I think there's a lot to do there. Well, we should start there. Yeah, Tulsi, what's up?
I know this is exactly rooted in like hard defined science, but as someone who works very closely with space and a lot of things we don't understand, do you believe in aliens or the Fermi paradox at all?
First of all, tell me, because the Fermi paradox, I'll definitely answer the aliens questions. Tell me about the Fermi paradox, about the way you understand it. And I'll land.
The way I see it is basically an argument, but like of the scale and probability of intelligent life that existed anywhere in the universe other than Earth.
Yeah.
And they have like 5 categories of like intelligent life based on where they could be technologically and just in general.
Right. And so I'm not sure about that level of detail. What I do think, just because of the vastness of our universe, is that there is probably some sort of life somewhere, whether it's like the type that we understand or in terms of, what in quotes intelligent life is defined as, where there's like, sociological systems and communication, like weird technological development. That I don't know. And I don't even know if I have an opinion on that. I do think there is life in the sense of like reproducing organisms or even self-reproducing organisms, or certain molecules that are indicative of life, like methane or whatever, these sorts of things. Do any of you know how many stars are just in the Milky Way galaxy by any chance?
Not off the top of my head. It's a lot.
It's a lot. A lot is the right number. It's like 100 billion. And then there's like 100 billion galaxies in the universe. So now we're talking 100 billion times 100 billion stars, like in the universe, is a very rough estimate. That's 10 to the 22 stars. And then around most stars is at least one planet. There's more planets probably than stars. So let's call it also 22 planets out there. Life is not easy. Like we know now just from our own solar system that you kind of have to be in a perfect zone next to your star that you're orbiting. So just like Earth, we get just the right amount of light and heat, and we have an atmosphere to protect us from the harmful rays that would kill some of the molecules that life. There's a sort of perfect set of conditions that need to happen. But when you have like 100 billion times 100 billion possibilities of that, you probably are going to get that somewhere. So this is why I think there is probably life somewhere elsewhere in our universe. But my feelings on whether there's life in the way we understand it, or the way we call it intelligent life on Earth, that I have no idea. Maybe not. I don't know. And I'm noticing in the chat, I just want to read it, another Lanel connection. Didn't Fermi pose this paradox while at Lanel? Maybe. That's probably something I should learn better. I don't know. It could be, but I don't know the answer to that. You're probably right. Do you all think there's life out there? And what type of life? Do you think there's like life we might communicate with someday?
I personally think there's a lot of planets, there's a lot of stars. I think there's like a 99% chance that there's other life out there. Because, like, why wouldn't there? I mean, at minimum, there definitely have to be other planets like Earth that have human-like intelligence and good space technologies. I mean, there has to be at least one. If there, that's crazy.
How are we so special? Yeah. I hear you. What about the rest of you? What do you think, Shaylee?
Yeah, much like you and Wyatt, I do think that there is a really great chance that there is some technical life out there. Maybe not, like you said, intelligent life, but so at least some sort of life form there has to be. The chance of there not being one and us being the only one, that's really, interesting, crazy. A lot to think about.
It's overwhelming almost to think that. What about you, Tulsi?
I completely believe that we're not alone. Like everyone else is saying, it would be extremely strange if we were, just by sheer quantity of other, just like the massiveness of space itself. Like there's got to be at least one other planet. No.
What about you, Hattie Rose?
Just because the universe is so big and we haven't fully explored it, it's kind of like the ocean. Like probably a lot of things in the ocean we don't know because we've only explored a small percentage of it. I think that there could definitely be something out there. I don't think it's going to be like the generic green aliens, but I think it could be like some type of life, even like a really, really small life, like bacteria or something that's somewhere else that could have been birthed by us. Like maybe something was in space and it touched on the planet and we didn't know about it, and then that like birthed something. I don't have a strong opinion about like whether there's like other civilizations.
Yeah.
But I feel very strongly that there is probably some other like living organism.
Totally. Yeah. I feel similar. It was funny. I don't remember if it was Tulsi or Shaylee or who earlier said something about one of the things they found interesting about space was that all around the world, we all have our own interpretations of things. Do you remember at the beginning? One of you all said that.
That was me.
So I made a note of that I wanted to come back to that because love that. I know you all spoke with Julia Bluebird, for example, who is a professional astronomer and does this amazing work on galaxy evolution. But she also grew up in the Lakota tribe in South Dakota and has her community's like interpretation of the constellations, which might differ from the Greek one that I learned when I was in school, and the stories that go along with it. That statement resonated with me of how we build our interpretations of the sky and the universe. Different cultures and different people have our different stories and interpretations. But there's something for me that's the flip side of that has made studying space really wonderful for me. And that is the fact that it's also unifying things. So although we might have different interpretations, we're all kind of looking up at the same sky. Maybe a different part of it. In the southern hemisphere, you're seeing different stars than I'm seeing in the northern hemisphere. But we're all looking out at the same universe from our little blue ball, our big blue ball, however you want to call it. And that to me is a very calming feeling and a very unifying feeling. And when there's a lot of conflicts and things going on around the world, when I think about how science and studying space brings us together, despite our different interpretations, it feels like a very unifying thing to me. All right, we'll wrap this up in the next few minutes. Yeah, I have to head out soon too.
Well, thank you so much for coming and talking with us. I got a lot of information just with talking with you, and it's amazing.
Thank you. Thanks so much for having me here. It was a blast. I would love to keep talking with y'all sometime and hear more about what you're doing and what you're interested in. Thank you.
Thank you for coming on with us. This is very interesting, very fun.
Awesome. Thank you. All right. Bye, everyone.
Thank you guys for joining us. Thank you to our reviewers. As always, if you want us to talk about a specific topic, just let us know. But with that said, I'm Shaylee.
I'm Tulsi.
And I'm Wyatt.
And we'll see you next time.